Hi, this is video notes 11 for Mr. Jury. These are the fun questions, the applications of polynomials that we will look at for our last section in our polynomial unit. In these questions, we'll look at polynomials that model cost or profit and projectiles. We'll also look at these crazy polynomials where you'll be given x-intercepts. You'll actually be given multiple, I should say some x-intercepts. You'll guess to find the factored form of those polynomials. But first, we're going to look at this profit problem. And a company wants to produce a bunch of Baby Yoda plushies estimated by the given equation. And it's defined from 0 to 60, and that's in interval notation, where X is the advertising expense in tens of thousands of dollars. So using the model, find the smaller of the two advertising amounts that will yield a profit of $2.5 million. So here we have a little graph, and if this is representing profit, so the Y values are profit, and the X value, that's how much money they're spending on advertising. We want to know spending. We want to know where is 2.5 million in profit, and it looks like it's about right here. So it's not quite at the vertex, or it's not really a vertex because this is a polynomial, and typically that term is reserved for quadratics and other things with just a single point. But if we look at the local maximum, it's not quite at the local maximum. The 2.5 mark is actually going to hit at two separate spots. So that's why this problem is asking for what's the advertising expense and find the smaller of the two X advertising expenses. So we don't want this one back here because clearly that is going to produce a larger amount of money for us to spend. We want this one right here, the one that corresponds to this lower X value. So that looks to be about 35-ish. So we'll see if we get close to that from our model. And you could do the same thing where you're just guessing on the graph if you pull that up, but we need a more concrete way of doing that. Right, so normally we would factor this or use some type of quadratic formula, but we cannot because this is a cubic and the quadratic formula only works for quadratics. So we have to get this 2.5 million number on the right side of the equation. And the only way to solve this one easily is to graph it. So with your graphing calculator or with Desmos, let's see if I have all my numbers in there. Yeah, or with Desmos, you can graph this function right here, and it will tell you the solutions to it. So it'll return some X values. And those X values will correspond to the X values we see in the graph that we've already predicted. And the X values you should get are 38.436 and X is equal to 46.071. So this means we would either be spending $38,436 on advertising, or we would be spending $46,071 to earn a profit of 2.5 million on our Baby Yoda plushies. So we definitely want this amount, and that is our answer. All right, for the height of a baseball, I'm going to throw a baseball upwards from a height of 6 feet off the ground. I'm not actually that tall, but I'm going to extend my arm that far, and with a velocity of 42 feet per second. So equation right here is a quadratic. That is fantastic because we know how to deal with a lot of the things that have to do with a quadratic. So our function is defined from 0 to 2.76 seconds, and you're told that the ball can go 35 feet into the air. Are you going to believe it? Now, you can figure this out a few different ways. You can graph it, you can see what the y value is, you can do something with an equation, and that would be completing the square. So we're going to do that with this equation, and I think this is the most concrete way to do it. So we're going to complete the square and determine the vertex. So h of t is equal to negative 16t squared plus 42t plus 6. Actually, this was supposed to be 32. I'm so sorry. 32. And we are going to complete the square with this. So we're going to factor out our negative 16. See why it had to be 32 now. Minus 2t. And then leave my plus 6 outside of these parentheses. Just completing the square. And then this number in here, it needs to be b over 2 squared. So my b is negative 2, so that means this has to be plus 1. So if I'm adding plus 1 to the inside, I'm not actually adding plus 1 to the outside. I need to, or I'm not actually subtracting 1 from the outside, because this number inside of my parentheses is influenced by this negative 16. So the number that I am actually putting into my parentheses is negative 16. So I need to add a 16 to the outside. And then my final equation becomes negative 16 t minus 1 squared plus 22. So apparently the claim that it can go 35 feet into the air is false, because the y value, and specifically the coordinate points of the vertex, is 122. So no, we don't believe it. And we are looking for, there it is. I don't know why it's all the way down here. We're looking at the last bit, which is going to be writing the factor form of a polynomial given some x-intercepts. So the x-intercepts we are given are 2 and negative I radical 2. So we need to make some factors out of these two zeros we're given. The first one, x equals 2, we know how that factor is written. That's written as x minus 2. That makes sense. X equals negative I radical 2. If you're not quite sure how to turn this into a 0, well, first of all, we know that this is also a 0 of this polynomial because it's a conjugate pair. X plus I radical 2 and x minus I radical 2 are both zeros. Then if we were to multiply these two factors together, then we can find the binomial that created these two factors, which is going to be more helpful to finding the fully factored form. So if we multiply these two together, we ought to get rid of the imaginary piece. And you might have seen something like this before, where we have x squared plus I radical 2x minus I radical 2x, and then minus the I radical 2 times I radical 2, which is I squared. Radical 2 times radical 2 is 2, so I'll write this as 2I squared. And this can be simplified, so x squared can't be simplified, but it's there, and positive I radical 2x and negative I radical 2x get canceled out, they subtract, and I squared is actually negative 1, so if I squared is equal to negative 1, then we've got I squared plus 2, because I've got negative 2 times negative 1. So this ends up being the factor for negative I radical 2. And again, we can, I'll write that like a factor, but we could solve for x and then see both of these zeros that we started with. But again, it's just, once we see this pattern, we know that the result to that factor is imaginary. So we ought to see the imaginary zeros and see the same factored result as well. That's going to take some getting used to, but we'll have some more examples in practice. Well, we already have two factors of this polynomial. So this polynomial is a 5th degree polynomial. So that means if we can divide out these two factors, the result should be a 2nd degree polynomial. And we can work with 2nd degree polynomials easily enough. We can factor those. And if it can't be factored, then that'll be our factored form. So we're going to divide we already know we have to, we could use synthetic division for, we could start this off 2, 1, 4, 3, negative 18, 2, and negative 52. We could do that, but I already know that I'm going to have to use long division for this this x squared plus 2 in order to divide that out of this polynomial. So I'm going to go ahead and just use long division. But before that, I'm going to multiply these two terms together to divide out cubic. So I know x minus 2 and x squared plus 2 are factors inside this 5th degree polynomial. So that means x squared minus 2x squared plus 2x minus 4. I just FOILed, right? I just distributed everything inside those two binomials. I know that this, that's a 3, this cubic is a factor of the polynomial as well, because we found the zeros and that led us to finding this cubic by multiplying our two factors together from those zeros. So we're following that trail of breadcrumbs, and if I can just divide out this cubic from the 5th degree polynomial, then I'll get our 2nd degree final factor. So I'm going to do long division, and you'll probably see me on the other side of some quick math. This has returned a remainder of 0, which is fantastic. That means I divided correctly. I don't need to go back and check any work. I've found a quadratic, and I could find the zeros from this quadratic if I really needed to, but that's not what we were asked. We were asked to just find the factored form. So we cannot factor this quadratic anymore because we'll find an imaginary result. So we're going to leave our factored form as the least factored form it could be without having imaginary factors. So we have x minus 2, x squared plus 2, and x squared, our final factor, plus 6x plus 13. There we go. And looking at B, I'd like you to try this one. The setup is going to require you to remember multiplicity. So you'll start off with the factors x plus 2 and x minus 2 squared, because we have an x-intercept at 2 with a multiplicity of 2. So I'll let you start that one and you'll see the answer when we finish the video. Hopefully you use synthetic division. Thankfully our factors are all linear and we don't have to worry about long division. And the factored result that we get out is this quadratic. And it cannot be factored any further. You can't find a number that multiplies to be 32 and both of them add to be -8. So the factored form for this last one is x plus 2, x minus 2 squared, and then times x squared minus 8x plus 32. There you go. I'll see you in class.